first thing we're going to do is bring in a parametric point. So let's go here to construct point. Then we can use an empty point component. So we can plug this point into it, but then we can change the location. So now that we have this point, we're going to move it here in the X direction. So let's go here to move. And I'm creating this parametric curve, but then you would be able to apply any curve to this. So let's go in the X direction, unit X, to move that. And let's say we'll create a slider here. So we move this point over by 15.5 or this amount, whatever this slider is. Now we can create a series of copies, but what I'll do is take this, move it out here and tap Alt to create a copy. And now if I plug in the geometry into this one, you'll see that it actually creates 2 copies. And if we were to do that one more time, then we create 3 points. Now, this is not necessarily a scalable model, but the reason why I'm showing you this is to create that curve. So now we're going to move this up positive Y and this in negative Y. So let's move this point, this one, and we will go Y direction and copy this over. Now what we'll do is take this one and we'll also create a copy of it, but this time rather than moving it positive Y, we're actually doing negative Y. And if we don't want to do that point, well, we actually have to do this point. So we'll plug that point into it. And we can disable the preview on the ones that we didn't move. So this one and this one. And now we've created a sine wave using either a interpolated curve or a NURBS curve. The reason why I show it to you like this is because they're similar, but they have some differences. This one goes through the exact point and it interpolates in between. And this one uses the points as a reference point attraction. And that's what this degree does, is it either makes it closer to those points or further away. So let's start with the first point, this one. It'll be red because when you just plug in one point, it can't create anything else. Now let's go to the next one. Holding down Shift, I'll add another input. Holding down Shift, I'll add this input. And holding down Shift, I'll add this input. Notice that it's a very smooth curve, and we can change the amount by changing the degree. So this is one way of doing that. We can also do this. We know that the points going into this are organized already. So if you double click on the input, you'll actually see that you create a relay. With this relay, now we can just plug that into the vertices here. And notice the difference that it creates. Let's see what the degree does on this one. So more than anything, this will show you how it kind of varies by creating more points and maybe interpolating it a little bit different there. So depending on which one you want to use, it would be the same process after this. So we're going to be picking the NURBS curve. So we'll get rid of this one. Now let's create this into a solid. So we'll take this curve, we'll extrude it in the Z direction. So we'll bring in a Z component to go up. And now let's extrude it by a number. So let's go here to 250. Maybe 200 could be the max here. what you want to make sure is that it's a smooth curve or a smooth surface, because now we're going to be subdividing this and creating the subdivisions for this. So once we have that extrusion, then we're going to go and divide it using isotrim. To divide using isotrim, you have to use divide domain squared and plug the surface into the domain and the segments into the domain input. Now we can change the subdivisions. So 1 less than 15 less than 30, and this gives me a custom slider that we can use here. Now the next thing we're going to do is, now that we have this subdivided, let's pick an item. So list item, which means we're going to pick just one of these surfaces. We're going to turn this into a triangle, because once we create this for one, we can actually create this for the entire subdivision. So starting with one, making sure that you have that really clean, that's what we'll be doing here. So using this item, we'll go to deconstruct brep, which means it'll explode this into its components, or into the things that make it up, which are going to be the points or the vertices, the curves, and the surface. So now here, let's go to vertices and pick or select or extract the 4 points, right? Because when you subdivide things using isotrim, you're creating square panels, and square panels have 4 vertices. So I'll go here to list item and actually go here to the plus and bring in 1, 2, 3, 4. So now this has 4 of those points. Within this component, we can also bring them out. We bring them out by bringing in a component, an empty point component, and now we can plug those into here. So now by disabling these, we can start now connecting the points to create the triangulated subdivision. So if this goes like this, then we know this is 0, 1, 2, and then close it. So let's do that. We pick 3 points and then close it using a polyline. So we'll go first point, second point, third point. Holding down shift, I'll add another one, and holding down shift, another one. Notice that it's open, so let's close it. We could either bring in the initial point and close it, or polyline, set boolean to true, and that closes that polyline. Now we're going to be doing the exact same thing, but in the opposite direction. So this one, this one, this one, and this one. So starting here, but we're going to go backwards. This one, and now it's closed. So technically we've truncated or subdivided this panel into half, basically. So now we can take these triangles, and since they're triangles, it can create a plane. So let's go to boundary surface or planar surface. Boundary surface is in Grasshopper and planar surface is inside of Rhino. So now that we know that and we know this, well, we can go here, and rather than having it do it just to one, we can go to graft, and you'll see that it'll actually do it to all of them. So that's a technique that, as long as things are organized here correctly, you can do it to one by ungrafting it and just doing this one, or this one, and then graft that entire set, which means it'll do it to all of them individually. So with this, we can disable preview. And now let's change some of these subdivisions, see what that looks like. These are some of the things that we have not changed, so let's see what that looks like when we change this. All right, cool. So we know that it works in terms of the subdivision, changing the curve and everything. We can also change this curve. So if I bring in a curve, empty curve component, this is what I want to have here, because couldn't we just go like this and just use any curve? Yes, we can. Now, obviously the subdivisions are going to be a little bit different, but that's kind of the idea, is that you can apply any curve or any outside shape that maybe you already have in your project, and you can apply this example to it. So we'll leave this here, group it, and I like to label it like this. So this is going to be set one curve. And then this, well, we'll do this. We'll bring in a curve component. And this is not necessary, but I just feel like you can kind of, you get the gist here, where this goes into a curve component and you can override this. All right, so before we go too much further, let me talk about a few things. I can start organizing and cleaning up all of these sliders and labeling them, but one of the things and some of the issues that I've had in the past is, let's say I'll relabel this, but then I'll want to reuse this, then I have to relabel it. So sometimes I find it a little bit more effective to leave them not labeled and then label them at the end once you already have all the sliders completed. So it's more of a, what I'm explaining right now is more of a logistics and techniques that you can use for organizing your stuff. But with that being said, okay, so we've got the subdivisions. We know that this is looking good. Now we want to create the brick wall. So how do we do this? Well, there are different ways you can attack this, but the way that I found that works for me is taking that original surface and we're going to offset it. So we're going to offset it either in or out. So offset surface, and we'll bring in a slider to offset that surface. So we'll go, let's say 5.5. Okay. So now we have this surface that's subdivided and the one in front of it or behind it that is not subdivided. We can actually do this -10 and go positive and negative. So whichever way you want to offset it, what happens is, let's say you'll have a project and you'll have a wall. Well, if you offset it from the inside to the middle to each side, it'll actually overlap with your wall. So let's say your wall was on the inside, then you can offset it to the outside, and that would work better because it would be on the outside and it wouldn't have any overlapping geometry. So in this aspect, you can offset it to one side, but if you have other applications, you can offset it from the center. Hopefully that makes sense. Now with this, we're going to take this entire portion of the script and copy it. The reason why is because we want to create all of the steps that we did for that surface, the original, to the new one. So let's bring this up, tap Alt. And so we've created the exact same set of steps, so it's happened twice. But now what we need to do is, rather than using this one, we'll use this one. And notice now that we have two sets here that we can join or merge. See if starting with the first one, then the second one. And we'll do the same thing here. So they are merged within one set of information. Actually, that may not work. So let me show you what we're going to do. Let's bring back all of this. Let me explain. If we merge them together, we won't have the ability to loft these two together. So what we need to do now is create the space for the mortar. What does that mean? That we need to offset the curve to the inside. So we'll take this and this. Now we're going to offset the curve. So we'll take this, offset curve. Now we need to make sure that we also use this polyline as a plane input. And now we can pick a distance. So we'll do 3.5. Notice that it's 3.5, but it starts overlapping. That's because it's actually offsetting to the wrong side. So 3.5 in the opposite direction. And we can do, maybe create a little bit more here. We'll do 0.25 or 0.5. We'll just say ½ inch. Okay. Now that we've offset that, we need to do the same thing for the other triangle. So all right, I think it's a little messy here. Let me disable the preview on this and on the surface, so we can focus on what we've done here. So let's go back to the surfaces here. These. Now I'm going to be using this and this as the subdivisions. Now we'll do this exact same thing to the two above here. So we'll take this, move it up, tap Alt, delete this, and then do the first one, plane, curve, and plane. So we have two sets. Now we can do the magic trick, which is a loft to create the solid between the first set and the first set. And this set and this set. Now we need to join these three and join these three. So we'll go here to join vrep. And we'll start with these, holding down Shift to add additional inputs. And then same here. All right, so now that this is here, let's disable the preview on everything and see what we've got. So let's flatten the input, look at 216, close VREPs, trim. Okay, something's going on here. Got this. This one and this one together. And the loft. Give it. Because I'm using the wrong surfaces here. Okay, let's do this the right way. So this is fixed. This one's done. Going to be this. This one and join those. Okay, got a little confused there for a second, but it's the outside the inside and the loft. And flatten the input, and we should have 100 closed B reps, which makes sense because we have 9 and 12. You can also lower this or change it. Okay. Let's now go back, disable preview on everything, and now notice that we have 2 sets of subdivided triangles, and now what we need to do is create the mortar in between. Because right now they're kind of, we have the ability to offset to create the gap, but we don't have the mortar yet. So let's do 0.25, something like this. All right, so now we need to go back to our surfaces. So these are the original surfaces, and they were subdivided into triangles like this. Now with these triangles, we need to create the mortar in between. All right, this part is going to be pretty interesting. So if this is the original and this is the offset, then we need to offset the original. If this is 5.1 negative, so minus 5.1. This one, here's the thing. I'll make this 5 here. And we actually need to leave it a positive number. Let me show you why. Because now we have here, let's say 2.7 to the outside, and I don't want it to be negative. Why? Because if this is to the outside, then I just need to offset this the opposite direction by how much I want the mortar to be in. So let me show you what I mean. Offset surface. Rather than in the positive direction, like here, right? It would be offsetting to the outside. Well, we can do 0.500 and offset that to the inside, so negative. And that's how much the mortar would be inset. So whether it's like, you know, 1/8 of an inch. See if we can do smaller number. 0.125. And the original is going to be a positive number for that. So using this, and rather than using the negative, you use a positive. So now we have these 2 sets of surfaces offset from the original that we need to subdivide and do the exact same thing that we did before, but we don't need to offset it. So, or we don't need to offset it to the inside to create the, you know, the offset. We've already created the offset here. So what we need to do is bring this down here and get ready to see how we can take this set of steps and just copy it. Basically, you can copy an entire set of steps and use them again, as long as you did it correctly the first time. So let's disable wire display hidden, wire display hidden. All right, we got these 2. Now we're going to subdivide it using this. To get not to offset, but to here. So to get a triangulated polyline using the exact same of subdivisions. So let's, I want to bring this up just because it's going to get in the way. Okay, move. Now with this, we're going to copy it. So move it down, tap Alt, and then you'll see this copy where you could place it. Now we're going to be doing the other side. See if this ends up showing up. And if we're going to do the same thing to the inside, well, we just copy this whole set of steps and do it again for the surface. So notice now that we have these two sets that are inserted, and that's actually going to be what is going to create solid subdivisions for that. So using these, we're going to loft, well, boundary surface to create a surface there. And then these. All right, I actually think that we do need to, no, we don't. With these two, we can loft them together the same way that we had it before, but not offsetting it. The loft, starting using this and this. Copy this and then do the same thing for the other set. Holding down shift to add more inputs. So this is where scripts start looking like, wow, look at how much work's been done. But the reality is that sometimes you take similar steps and copy them over to create, you know, your final result. These could also be simplified into clusters, right? Like I can create a cluster that just subdivides into a triangle, kind of like this, and simplify it, but I want to show you all the steps on this. So once this is lofted, then we can join it with this. So if these two create a loft, well, this is the cap of one side, this is the cap of the other side, and this is the loft. Same thing here. This is one side, this is the other side, or I messed that up. This is one side, this is the other side, and this is the cap or the ribbon in between. And then flatten the input here and flatten the input. 108, 108, and 108. So we have 108 subdivisions on this. And let's disable the preview on everything except for the last parts. So this is inset. So what we need to do, let's see. All right, let's color it up so we can see, we don't see through everything. So using custom preview. Okay. Let's do this and this. I'm using color swatch. Use a lighter color for the ground. Maybe even dark here. All right, next one, it's going to be brick. So let's bring this over and hold or override it by not holding down shift, and then hold down shift for this one. Let's go back here. Let's increase the depth here. Let's just say like 6 inches for the wall. I think the last thing we could do is take these and give it a transparency. Let's see if this works. Okay, so if we've created this surface on this side, why don't we offset this curve in the negative direction by a little bit. So I'm copying over that slider. And then also to this one. Maybe that's the depth of the brick size, right? Now let's do the same thing to the other side. Now I can't guarantee this is going to work, but let's try it. Why not? Same thing on the other side, right? So now what do we need to do? Let's disable the preview on all of this because technically that's old, and what we need to do is take these and the originals and loft them together. It's a lot of stuff, huh? But that's all right. So let's go this one and this one. So we'll loft those one at a time. This one and this one. We're also going to do the inside, which is this, and hold down shift and add this one. Now this and this, let's see, this and this can also create a surface using boundary surfaces. Flatten the input on that one. Let's see if that works. Okay, so now we have that side. Now we need to do the other side. So for that, we have this inside and we have this outside. So being careful, I'll do outside, hold down shift, and then inside. All right, we got one set of bricks here. So now joining these. And here's the thing. Inside of Rhino, you would have to do every single one or create a block and then change it. And then you can't use a curve attractor and those kind of things. So this is really the power of parametric design and Grasshopper, is that you have the ability to do one step to multiple things at the same time, and it does save a little bit of time, but that's not necessarily the point. It's that you can see the things update right away. So let's go back here and show you that. Okay. At this stage, we need to do the next one. So I know it's going to be the exact same set like this, but down, and doing it again. So to the other side. So this side was first, and then this side. So this side, then that offset to here, and then this creates the outside. Nope, that's incorrect. All right, let's try that again. Disconnect all. Okay. We've already got this one, so it's this one and this one. going to be the loft there. So between that and that is the loft. Because we'll start with the lofts here. This one. And this one. Next is the other loft, which is going to be this one offset to the inside. And so it would be also this one. So these two lofts together. All right. So we got these two. Now we need to create the surfaces in between. So if this and this, not this. If these two create a surface, then that needs to be inputted into the surface here. All right, last one. It's going to be this one and this one. Now if we look here, there we have all of the objects, which means that all of this is old, right? So now let's plug in this into the custom preview, show it, and then hide this. So now this has been subdivided into having a gap on the inside, and it could be whatever size. So this would be a depth of 3 inch on each side. It could be 1 inch for transparency. So now let's do this. Let's bring back the mortar portion, or the grout. All right, so when we bring it back, we have this overlapping. So now we need to fix that. And it's basically doing the same thing. So we've created these two forms that are joined together using these lofts, but we actually need to go back a little bit on this. And here's why. Because we now need to offset this by the same amount of the mortar to create that look. So let's do that. Delete this, hide everything else. Now let's do that. Let's focus on this. So to take, let's see here, 2 sets, 1 set, 1 set. Okay. We're going to offset it to the inside by the same amount as this. Or actually, no, this. So we actually need to bring this into a number component, hide or wire display to hidden, so we can bring this down and use it. Because we're going to be offsetting all of these by that same amount in the negative direction. So we know we needed to offset to the inside. So by doing this, we offset it to the inside. By copying that, we're offsetting the other set to the inside, and we'll do that one more time for the other side. Great. So now that we've offset it, we now need to create that surface in between. So loft, and then we'll go from here to here. So this one, oh no, that's incorrect. We're lofting from the outside to the outside. Now we're going to be doing also the outside and outside. Let's see. Now these are together and these are together on the other side. So lofting, this and this and this and this. All right, so now let's create the surface in between those two. We can also use Boolean difference, but with all of these bricks, it'll actually take forever. So it's better if it's more of an additive type of modeling here. So using the original and then the offset creates a surface there. Boundary surface. Flatten the input. Same thing for the next one. Okay, so those. Outside, inside, outside, for those, and then the other side. Okay. Using outside, okay. This one, this one. Okay, now that we have this one, in those two, we have to do the same thing to all right, now let's join them. So outside, ribbons inside, and surface. Actually, yeah, this is the outside form of it. So joining all of this, it's going to be interesting, but we need to do one at a time first. So this one, this one, this one, and now the inside. All right, we got half of it. So with this, now we're going to do the other half. So join derep. You've already got this side. Now we're going to do the other side. This side, one. Got that, and then this one. All right, we can do this an easier way. Copy this down. That needs to be joined. Then this one, and this one, and this one. Oh. This one, This one, holding down Shift. Okay. Now let's override that with this one. So at this stage, when we look at the script, what we've done is created a set of bricks that are subdivided and triangulated. Then we create the brick subdivisions with the gap for the mortar, and it also has a gap here. So that is determined by this offset. That is 0.125, but if I wanted it to be as drastic as, let's say, 1 inch, this is the kind of look that we can get. So let's go here to 0.5. So what I'll be doing is sharing with you this script on my website if you want to download it. This tutorial is more than anything sharing with you guys different exercises so you can learn how parametric design works and so you could use them for your projects. That's the most important thing. So thank you very much for being here. Hopefully you found this interesting. I know it's a lot of work. I know I went over a lot of things, but if you have any questions, I would love to help you with this. So thank you very much for being here, and I hope to see you on the next one.